This is part 12 of the Module 9 lecture, and this is the last part, where we're going to talk about a specific example where we compare the proportions of two independent populations. This is the example we started this section with. This is where a medical research team conducted a study to see the effectiveness of a cholesterol-reducing medication. So in this study, they had 4,700 people took the medication. Of this, 301 died of heart disease. And they had 4,300 selected randomly, and those took a placebo. Of those, 357 died of heart disease. So at a significance level of 0.01, we want to find out if that death rate of the proportion of people that died that took the medication is lower than the proportion of people that took the placebo. And when I said the proportion, I'm referring to the death rate of those that took the placebo. And also we want to calculate the 99% confidence interval and interpret the results that we obtain. All right, so in here, let's summarize the information that we have. So the samples are, these subjects come from two populations. They're different subjects, those that took the medication and those that took the placebo. So these two populations are independent. And the parameters of interest are, of course, the death rate of those that took the medication, pi sub m, and the population proportion of the death rate of those that took the placebo. All right, so now using the information they provide us, which is the sample size and the number of people that die in each of the groups, from those numbers we calculate the sample proportions. So the first sample proportion is a proportion, or you may say, the death rate in the sample of those that took the medication. And so there were 301 deaths out of 4,700. So that proportion is 0.064. The death rate of those that took the placebo, there were 357 that died from heart disease, and out of the 4,300. So that proportion is 0.083. So these are the 2-point estimates of the population death rates. All right, now that we have that, we can start now with our procedure to test the hypothesis. So remember, in the problem, the objective is to see if the death rate of those that took the medication is lower than those that took the placebo. So they're quoting the alternative hypothesis, which is right here. The death rate of those that took the medication is smaller than the death rate of those that took the placebo. Under the null hypothesis, of course, is that these death rates are equal, or maybe the death rate of those that took the medication is higher than those that took the placebo. All right, so changing this hypothesis into a difference of proportions. So the alternative hypothesis is that the death rate of those that took the medication minus the death rate of those that took the placebo is less than 0, because we're expecting this proportion to be smaller than that. So that's a negative difference. So that's why it's less than 0. Under the null hypothesis, we expect this proportion to be equal or larger than the proportion that took the placebo. That's why that's bigger or equal than 0. This is a left tail test with a significance level of 0.01. All right, what's the distribution to use? Well, these samples are from two independent populations. And we can assume that these come from a binomial experiment, or that these are two binomial experiments. And by looking at the number of the product of the number of individuals in each group times the number of successes and times the number of failures for each of the samples, you see that every case these numbers are larger than 5. So we say that we have a sample size that is sufficiently large, and therefore we can say that the sampling distribution of the difference of proportions can be assumed to be normally distributed. All right, now we know that we're using the standard normal distribution because the sampling distribution of the difference of proportions is normal. All right, now under the null hypothesis, you notice that we're assuming that these two proportions are equal. So because of that, then we calculate the pool estimate of the proportion using the number of successes in each sample and the number of individuals in each of the samples. So if you carry out that calculation, that's 0.0731. Then once we have this, we calculate the test statistic, and the difference in proportions is from those point estimates that we calculated. These are these two numbers. And under the null hypothesis, we're assuming that this difference is equal to 0. Then using the pool estimate of the proportion, we calculate, put it in here, and then we take the inverse of the sample sizes. Again, if you carry out these calculations, you find that the Z observed is minus 3.46. All right, now if you decide to follow the critical value approach, this is a left tail test, so the rejection region is in the lower end of the probability distribution, and that's that Z observed will be less than Z critical. If that happens, then we reject the null hypothesis. But again, we need to go into table 4 with an alpha of 0.01, and we find that the Z critical is minus 2.33. So the rejection region is if the Z value is less than 2.33. So if the Z observed, the calculated statistic, is smaller than this number, well, we will reject the null hypothesis. If we decide to go with the p-value approach, then we use the Z observed, minus 3.46, and then we go into table 4 and we see what probability this corresponds to. And the probability you can see in table 4 corresponds to 0.0003. So since this is a left tail test, the probability that Z is less than Z observed, or that minus 3.46, so the p-value is in fact 0.0003. All right, so now you can see here that the Z observed is smaller than the Z critical of 2.33, and the p-value is smaller than alpha 0.01. So from both conditions, you can see that we should reject the null hypothesis. So the difference in these two proportions is larger than 0. So we can say that by rejecting the null hypothesis, so we're saying that we reject that, so this difference is less than 0. That means that then the death rate of those who took the medication is smaller than those that took the placebo, because this proportion is going to be smaller than this, so that the difference is negative, less than 0. All right, with that deduction, then we can see that at the 1% level of significance, there is enough evidence to conclude that the population death rate due to heart disease is lower for those who took the medication than those who took the placebo. And again, the limitation of that hypothesis test is that all we can say is that the death rate of those that took the medication is smaller than the death rate that those that took the placebo. But the natural question is, well, how big is that difference? So in this case, it is a good idea to go ahead and calculate the confidence interval to estimate the actual difference in death rates. All right, to do that, then we use the confidence level of 0.99. Then we go into table 4 with an alpha divided by 2, because alpha is 0.01 divided by 2 is 0.005. And then you see from table 4 that this corresponds to a C alpha over 2 of 2.575. Then using our point estimates of the proportions, the alpha value that we obtain, and each of the point estimates and the sample sizes, we can calculate the margin of error, subtract that from the difference of proportions, and we get the lower confidence interval, which is minus 0.0332. Doing the same calculation, but now adding the margin of error to the difference of proportions, the upper confidence interval limit is minus 0.0048. All right, so now we need to interpret these results. So the 99% confidence interval for this difference in population proportions is minus 0.0332 to minus 0.0048. So, but these are negative. So the negative signs indicate that the death rate, so if, in other words, the difference between these two death rates is negative. That means that the death rate of the placebo is larger than the death rate of those that took the medication. That's why this difference is negative. So, and that's what I'm explaining in this part. So, with that knowledge, then we can say, interpret the confidence interval in a more meaningful way. So we can say that at a 99% confidence level, the actual death rate of those who took a placebo is between 0.48 and 3.32% higher than the actual death rate of those that took the cholesterol-lowering medication. So you can see that this medication seems to reduce the death rate. Not very much, but perhaps enough to start marketing this new drug. All right, this is the end of this example, and this is the end of all the topics that I wanted to discuss with you on Module 9. So the Module 9 assignments has, as you can see, 5 parts, and part 1, A and B, you already worked on it, and part 2 and part 3, 1 and 2 you already worked on. Part 3 and part 4 you will work on them this week, and this last part will be for the following week. All right, but just to avoid any confusion, look at the due dates on Wiley Plus, or look at the calendar on Wiley Plus. All right, so at this point, the expectation is that you should be able to distinguish between 2 independent populations and 2 related samples, and that you should be able to identify the correct approach depending on what situation you have. So if you have independent populations with a continuous random variable, then you might be comparing variances, or you may be comparing means under the condition that the variances are equal or that the variances are unequal, or you may be having, and now if you have dependent samples, then you will be looking at a continuous random variable for calculating the difference of those. And of course, it is expected that you should be able to carry out the hypothesis test and calculate the confidence interval for any of these situations, and you should be able to interpret the results. And that's an expectation that in the exam will be very important, be able to explain your results. All right, so we're done with Module 9. I know it's a very long module, and that's why I spread it over about 2.5 weeks, but we're done with it. All right, so this is the end of the Module 9 lecture.